Circular queues. A circular queue is a type of queue structure in which the last position is connected back to the first position, forming a circular or loop like structure. This allows the circular queue to utilize the memory space more efficiently by reusing the space which was left behind by the dequeued elements. And here so far we discussed the like in a normal queue the insertions can be performed at only one end and deletions can be performed at another end, which is called the rear as well as the front, right? So look at this linear queue. When you check this linear queue here, look at this linear queue. This shows the linear queue and the size of the queue is 7, which means only 7 data elements the queue can hold up to. If you check, the queue is completely full. To check for the overflow condition, overflow means when the queue is completely full and when there are no more insertions can be done, which is called the overflow condition, right? When to check for the overflow condition, the actual condition is going to be, while writing the pseudocode, we'll write like this, right? If rear is equals to max minus 1. When rear is equals to max minus 1, which means when the rear is pointing max minus 1. Here the max value is 7, which means maximum 7 data elements it can hold, the queue can hold up to. And if the rear is pointing 7 minus 1, which is 6, if you check, yes, rear is pointing 6, which is max minus 1. If so, the queue is completely full, we will not be able to insert a new element, right? So this is the overflow condition, and now this linear queue, if you check, it is completely full. Now if you want to insert another value here, it shows overflow condition only. Check this example, queue number 2, this is queue number 1 and this is queue number 2. Check queue number 2. Now you want to insert another value, one more value you want to insert, but it is not possible because the queue is completely full here, right? But here when you check, you want to insert after deleting 2 elements. Since it is completely full, I have deleted 5 and 10 and the resultant queue has been shown in queue number 2. Now 2 deletions has been made, which means there are space left here in the queue to insert a new data element. But if you check for the overflow condition again, still it would show overflow only. Why? Because the rear is still pointing max minus 1 only. Because it is a linear queue, in a linear queue always the front would be pointing the first data element and the rear would be pointing the last data element. Suppose if the rear pointer is pointing the last index, which means that it would show that the queue is completely full, right? So though we have 2 places here, the spaces are there to insert a new data element, still in a linear queue it would show that the space is full because the overflow condition here is when rear is pointing max minus 1, right? So to avoid this, we can prefer this structure, which is queue number 3, which is a circular queue structure. So here we can make use of the spaces very efficiently over here. Suppose if you are performing the DQ here at the front end, though the rear is pointing max minus 1, if there are spaces here before the front pointer, we can make use of it efficiently using the circular queue structure. So if you check the queue number 3, third example, there are spaces here with the help of the circular queue structure. Suppose if your rear is pointing max minus 1, and as a next step, after if you want to insert a new value, at a next step you have to check if the front is not pointing 0. If the front is equals to 0 and rear is pointing max minus 1, means it is overflow when it comes to the circular queue. If you check here, my front is not pointing 0 but rear is equals to max minus 1. Both should, front should point 0 and rear should point max minus 1. Then only you could say that if you check here, yes, front is pointing 0 and rear is pointing max minus 1, this is overflow. But here if you check, the front is not pointing 0, it is pointing index position 2 and rear is pointing max minus 1, which means the overflow condition doesn't occur here. Why? Because there are spaces left, my front is not pointing 0. In such case, you can do that, you can increment the rear case. If rear is equals to max minus 1, you can set your rear pointer equals to 0 and in the place of rear you can insert a new value when it comes to the circular queue. So the main use of the circular queue is overcoming the drawback of a linear queue. So we have 2 solutions. One is first to shift the elements to the left. After, like, since there are elements, once there are spaces, once deletion has been made, if you shift one position to its left, that is one option actually to make use of the space, to make use of the space efficiently. This can be done, but the thing is, it is very time consuming process, especially when the queue size is very large. So to avoid that, we can go with the circular structure. In a circular queue, the first index comes right after the last index, means it will form a circular structure, right? So this is the first index, it comes right after the last index. Now it forms a circular loop like structure, right? Now you can make use of the space, you can reuse the space, the dequeued spaces very efficiently here in the circular structure, and I mentioned the condition here. So when it is in a circular form, if you check here, I have made exact circular queue representation over here, queue number 4. If you check here, like queue number 4, in the index 0 and index 1 is completely free, and front is pointing index 2 and rear is pointing max minus 1, which is index 6. If you check after traversing to the rear position, which is a queue of 6, which is the last position, it has to move on to the next position. When it is completely full, you set rear equals to 0 and you can start performing insertion here efficiently in a circular queue like structure. So this is the major advantage here in the circular structure. We cannot waste the space here in the circular structure, but when it comes to linear queue, though there are spaces left, if the rear is pointing max minus 1, definitely it would show the overflow condition, but in circular structure we can completely like make use of the spaces very effectively to store the data elements. When it comes to the properties, there are 4 properties. One is circular nature. The end of the queue wraps around to the beginning when the end is reached, right, here in a circular queue. So effectively we can make the queue in a circular form to make use of the space properly. And the second property is fixed size. Like a linear queue, a circular queue has a fixed size. However, it efficiently uses the space by reusing it, but since we are fixing the size here, especially when you use an array data structure, it would show the overflow condition when the front is equals to 0 and rear is equals to max minus 1. And third property is, we use 2 pointers here. One is front pointer and another one is rear pointer to keep track of the front and rear end of the queue. And fourth property is full condition, the overflow condition. So when the overflow condition would occur means when the next position of the rear is front, which means when rear and front is nearby, which means it is overflow condition. So these are the properties of circular queue, and in the upcoming videos let's discuss how insertion and deletion can be done in a circular queue structure.